Hey guys, Paul, Inventor 3. I got one of these things, a new addition to the laboratory. Good guy, a co-worker of mine, Austin, his name is. He made a few of these, so he gave me one. It's really cool. I forget what they call this. It's a cube inside of a cube inside of a cube. But yet at the same time, it's a circle inside of a circle inside of a circle. Yeah, it looks cool when it spins. Anyhow, okay. I just wanted to show you that real quick, and let's move on. I'll get my camera out of here. There we go. Okay, this is our schematic. Now, I showed you this in the last video. This is our frequency generator. It goes around, 2 coils, positive, negative. They go to 2 plates. A third plate, pickup plate. Goes to another coil, 10 LEDs, jumbo white LEDs. That's the negative and positive end of the LED string. Doesn't really matter though, but anyhow, earth ground. Oh, and those coils, they're like 80 megahertz, 25 feet. I think I got that right. 2 3/8 diameter on PVC core. That's the diameter of the core, the PVC. And it's made with what they call magnet wire, or sometimes they'll refer to as transformer wire. It's an enamel coated wire, 0.032 diameter, 32 thousandths of an inch, 20 American wire gauge size. Okay. So here we go. Oh, I hung this poster today. Nice frequencies chart, basically. Cleaned off my board. Added little tiles down here. Crappy ones I had in the garage. Anyhow, yeah, looking good. All right, now next thing I want to show you guys with the project here is I'm ready with these different size coils. I'm ready with a bunch of LEDs. I spent hours today soldering many, not just these. I have a whole box full of them, but strings of LEDs where 1, 2, or 3 LEDs were burnt out and I had to replace them all. So I spent a good portion of today doing that. Anyhow, let's see. I don't know if I mentioned it last time. This is just my power supply unit. I could here. Let's see. There's one right here. Let's see. Where's the negative? There's the negative. Let's see how much this takes to light up. There they go. Just coming on right there. Okay. And you can see 25, almost 26 volts. Okay, so that's why I like having that there. To have to check my LEDs all the time. And this before, I think I mentioned, that's just an AV plug, Avermenko plug. Again, it's just 2 diodes, reverse direction of each other, and an LED and a wire. It's not physically connected. It's just there as a visual aid. I can see when things are resonating. Okay, right now there's our 12 volts, 3.15 megahertz. There's all my LEDs right now. Let me adjust the frequency a little bit. That's about it right there. So believe me, they got about 25 volts across them too right now. But let me show you this real quick. Now that we've got our apparatus, woohoo! Now we can see real quick. And I think I showed you this in the last video. If I go up or down, the LEDs will go out. These LEDs have a narrow viewing angle. That's why I gotta be aiming more at them with the camera so you can see them. Okay, anyhow. Now if I let's do this. Well, let's go move apart. Oh, they just went out. All right, let me go back down. There's where they're on. Move apart. They're off. Okay, now we gotta come down here. Now what are we at? 3.28. Now they're back on. So that's something I gotta play around with now to see if there's a best point and frequency. It's interesting to note that the higher that I increase the frequency, the more distance I need between the plates in order for these LEDs to light up. I have to think about that. Because I also think about the space, wave, smaller of a space, the more, microwave, closer, smaller waves you get in between. But this is different. So we can keep doing that, and I'm going to keep doing that. I'm going to go off camera now because I have to set up my camera here. So let me pause it for a little bit because I got to see now, is it better real far apart, large distance, high frequency, or is it better smaller distance, lower frequency? I'll be right back. Okay, you know what? I'm going to bring you with on this experiment. I was luckily able to adjust the camera there and get it up at just the right height. It's sitting on my table. Alright, first of all, I want to show you one thing. Let's see, one guy mentioned about the distance. Let's see, is there another one and a harmonic of this distance? I'm not going to measure it exactly, but let's see if those LEDs light up at a different distance. No. No. Let's go back to our spot here. Hold on. Where's it at? There we go, right? Somewhere, whoops, right? Yeah, somewhere in there. Okay. Now, all right, we are at 3.150 megahertz. Now, you tell me, guys. I'm going to start moving these plates apart. Each time I do, I have to adjust the frequency higher to get the lights, the LEDs, to light up again. I'll watch this back myself, but I got to see if they're brighter or not at more distance or not. Let's see here. Open. Turn up frequency. Open it more. Turn up the frequency. Open it up some more. Turn up the frequency. Somewhere there. That's not bad. I almost want to say that is brighter. I'm not sure. Let's go a little farther. We're at 3.5 megahertz right now. Right there. 3.590. Huh. A little bit farther. Oh. Huh. Not bad. Alright. Alright guys, let me end that little clip here and let me think about the next thing, because I don't know when I want to watch this over too here. Gotta watch this myself. Alright, we'll be back. Okay, well what's next is we gotta change our coils. Hey guys, alright, I just wanted to show you this real quick. I got my jet heater running in the background again. I hope it's not too annoying. Let me know if it is annoying. I always try to talk loud enough. As you can see, there's the LEDs are lit. I'm kind of close distance right now. And where's well, I'm at 2.9. I got my phone on the tripod. 2.93 megahertz. Yeah, I know someone mentioned about there being, is there a second like sweet spot harmonic distance, and yeah, many times I have had multiple resonating points, so that's not uncommon. Now let me show you this. Let's see, I'm trying to get the whole thing in the camera's view here. Let me see. There we go. We can see. There. Okay. Opening the plates apart. Lights go out. I keep going. Up. Little fine spot. Eh? So you always got to watch out for that too. Multiple resonating spots. I think you got to marry the distances here together with the best frequency over here, the best coils, and like I said, I think the answer is going to be in higher frequencies anyhow. But yeah, I got a lot of good experiments coming up here. I don't know if I'll have time tonight to film some more. Maybe, maybe not. Woohoo! Oh, this is so nice now. I want to try things like all different things. Larger diameter wire, more Q, more charge. Also, yeah, more space between the wires. Dissimilar metals. Let's see how that works. I just got aluminum plates right now. Let's try aluminum, copper. And another thing I'm anxious to try is very shallow pan of water as transmitter and receiver plates. And it's already been shown that water has memory, so this will be very interesting. Another thing I want to point out is, you know, I might have to go back to my secret sauce, which is the transmitter being one plate and a receiver wrapping around that transmitter. Let me show you this real quick. What I'm going to do on these three plates, let's see if I can get my hand under here. Ooh. Okay, I'm going to disconnect that negative plate. Ready? Hold on. Bam. You see how much brighter they get right away? Oh yeah, that's definitely over 2.6 volts each LED now. But there's still a lot that could be done with this too. But for now, I'm going to continue on with keeping this attached, and we'll see what else we could do with combinations of coils here real quick. I've already tried increasing this one to larger, double and quadruple the lengths, harmonics, but so far nothing. But I gotta see what if I make these the same, always keeping them equal, or maybe these larger and this smaller. Alright, so anyhow, we'll be back, guys. Okay, let me show you this. Now I got that big coil in there. Okay, that's the only difference. I'm searching all over the frequencies here, going up and down with the plates. But then I happen to remember, let's do it again without the ground. They're nice and bright. Now my plates are very close though. Let's see if I separate them. Is there another? No. But they have to be very close. Alright, we'll be right back. Okay, I switch back to this coil, but then we need the ground again. Now our plates are kind of close, but we're only at 2.1 megahertz. So I'm going to assume, let's go to 2.2, and let's start opening our plates up. There we go. Now we can keep playing around with that. Get the higher frequency. Those are pretty bright. Alright, we'll be back. Now, the question still rises here is why, if I go with a larger coil, do I suddenly not need the floating ground? Okay, this is interesting that we started at 2.1 megahertz with this coil and that, and I showed you how bright they were. And I went up to 2.2, open the gap a little bit, light back up. Go to 2.3, LEDs go out, open the gap a little more, they light back up. Now we did this earlier, and it stayed very bright the whole time until I had very large gaps here. But this time I'm at 2.4 and it's already not as bright. I cannot get it as bright now, no matter what. Let's put this back to 2.1 here. Oh yeah, that's bright. Actually, yeah, they're at the point now where they hurt my eyes to look at them. Anyhow, interesting to note. You know, one time we're able to keep going, opening it up really large. One time we're not. All these results keep confusing me. Anyhow, we'll be back. Alright, well, 2.1 megahertz. We're still at that 12 volts. I got 20 LEDs. They're not as bright now. Now let's play with this distance a little bit. At one time, very sensitive spot here. Little adjustments gone. I'm going to spread them apart. Now, one time when I do get a second frequency. So, yeah, it can get really tricky. Is there a third one? No. No. And I'm going to try it too to see if I can get it to work without... Here, let's do it real quick. Will it work without the ground attached? In. No. Now I can still play around with the frequencies down there too. Alright guys, we'll be back. Okay, there you go. Now these 20 LEDs are lit up very brightly. Now I got this taller coil in there. It's 4 times. This is about approximately 25 feet. This is approximately 100 feet. It's like 98 feet, so many inches, I forget. I should have made it exactly even, made life simple, but anyhow, yeah, they're all lit up pretty good. That coil, oh, and I even took that floating ground off. And here, I also added something else we could experiment with, which is an actual earth ground. See, one of the wires goes down to our plates. One now comes over to the rod in the ground. It's about maybe 10 or 12 inches deep. Okay. So, like I said, now there's no ground. Small distance. Alright, we'll be back. Okay guys, there's 40 LEDs all lit up bright. There's at least 25 volts, I guarantee, across each one of those. And these strings are all in series with each other. So this is a minimum right now of 100 volts. Okay? Yeah, those are nice. 2.23 megahertz. And we're still only putting out 12 volts. The most this could put out is 100 milliamps. You got it right there. Maximum. Or not though. Anyhow. That's nothing yet. I keep saying that, don't I? This is nice. I like this setup. This is very nice. Yeah. I don't like that there's wasted energy though. Alright guys, we'll be back, I think. Just showing you real quick. I'd like to show you the voltage across those LEDs, but as soon as you hook up your voltmeter across those LEDs, throws everything out of resonance. Okay, we got it now. Let's see, that's 2.23 megahertz at 12 volts. And here we go. It's like 60 LEDs, super white, bright, 10 millimeter jumbo LEDs with the dang narrow viewing angle. Anyhow, they're all lit. So that's 150 volts at least right there. 25 volts across each. 25, 25, 25, 25. There's no way in the world my power supply can only go up to about 30 volts. You got to remember now, I've said this before, an LED is 4 different things. You know, it's a diode, it's a one-way valve, it's a spark gap, it's a resistor, and it's a capacitor. It has to build up a certain amount of an anode to jump to the cathode. in the junction there. So anyhow, okay, so that should be enough to light a bulb now. We'll be back soon.